Hey everyone, welcome to the second example of static equilibrium, and in this one we have a 100 kilogram mass supported by two ropes. We've been given the angles and we've been asked to solve the tension force on each rope. We start off by finding the gravitational force of this block pushing down. Force of gravity is no problem, it's just mass times gravity, and we get 981 newtons. That's the force that's pulling down. We know that the other two ropes combined have to be pulling up. So the left one pulls up with a y component, the right one pulls up with a y component, and combined they have to equal 981. If they didn't, the block would come crashing down. To get those vertical components, we use the force 1 sine 40 plus force 2 sine 30. That's vertical components. We're just breaking it into vectors. Our left force and our right force. We also know, so that this block doesn't go swinging left and right, that both of the x components have to be equal. To get the x components, we use cos. Force 1 cos of 40 must equal force 2 cos of 30. That's the only way that this block is going to stay in place, is if all of that is true. But we don't know force 1 or force 2, but we can do substitution. We can rearrange that bottom equation such that force 1 is equal to force 2 cos 30 divided by the cos of 40. Now that we know what force 1 equals, kind of ish-y, we can actually substitute that back into the first equation. Yay for substitution! And what we're going to end up with is a new first equation, which is 981. Fill in our new value for force 1, which is our F2 cos 30 over cos 40. Still multiply it by the sine of 40. Still, don't forget to do that. Still multiply it by the sine of 40, and then add the force 2 sine 30. It might look messy, but coses and sines are just numbers in the calculator, and this actually cleans up not too bad, so that we get 981 equals 0.7267 force 2 plus 0.5 force 2. If you got this far, you got this made now. Those add together very nicely to give us 981 equals 1.2267 force 2. We can divide both sides. I'll just move this up here a little bit, give ourselves some room to finish this. To get that F2, we divide both sides by 1.2267. And this should give us our force 2, which is going to equal, dun da da da, we chug this into the calculator, and we are left with a force 2 of 799.7 newtons. Now that we know force 2, we can actually plug it back in up above where we knew what force 1 was. Because we know that force 1 is equal to force 2 times the cos of 30 divided by the cos of 40. We can see where we subbed that back in. We can chug this out in the calculator. We get our force 1 now by multiplying that out, and we get that force 1 has a tension of 904.1 newtons. It's a different trick. We weren't given either one of the tensions to start. We were just given two angles, but using substitution, we were able to solve the two tensions. And this is just another type of static equilibrium problem. I hope this was helpful for you.